Toastmasters and welcome guest. How much would you spend to learn how the universe was created? How much would you spend to learn how people came to be? How much would you spend to find cancer before it's incurable? $10,000, $1 million, $50,000. One of the problems right now is that the government is very short on money. And this is common, seems to have happened throughout history. And most of the people who are elected are not scientists, and they don't see the value of general science. They understand, oh, I'll pay you X amount of dollars to find a cure for cancer. I'll pay you X amount of dollars if you can tell me how the earth was formed. I might pay you a little less if you can tell me where people come from. But if you have a specific goal in mind, you'll get some people who are willing to chip in and pay for you. The trouble is that most of them don't want to pay for just general science. For example, having a science officer on every ship, just sailing around the world, don't have a specific job. If they see something interesting, they should write it up and then just investigate, see if something came up. Well, about 150 years ago, a young man joined the Royal Navy as a science officer and went on a trip around the world with the naval ship Beagle. And he was a science officer. He didn't really have specific duties. He was supposed to bring back anything that he found interesting. And so when they landed on strange, exciting islands, he would gather up all of the little fronds that he found that he'd never seen anything like. He would look at birds and draw pictures of them and say, oh, look at this bird is a finch and it's got a beak like this. This bird is a finch and it's got a straight out beak that's much longer. What could be going on here? And he just kind of wondered about this. And the ship sailed for, I think, 18 months, and he had tons of notes. He would kill the birds and stuff them so he could take them home and show them to people, all kinds of things. When he got home, he had many, many, many trunks full of things that he had picked up along the way. And then he spent the rest of his life writing about what he thought he had seen. And his name was Charles Darwin, because of what he had seen as he traveled around the world as a very lowly science officer. He was paid very little money. He was able to create the concept of evolution. He could see that this bird, which ate this kind of food, had a beak that was just perfect for eating that kind of food. And then this other bird that was related to it, but ate a different kind of food, had a different kind of beak. And he wondered how that could be, and he figured out that things must adapt to their environment. It was a total revolution. Prior to that, and even after that, people thought God made things, and they stayed the way they were made. So God made this kind of bird, God made this kind of bird, God made that kind of bird, and put them down exactly where they needed to be so that they could eat their stuff. He had a different theory, and over the past 150, 200 years, it seems to be holding up. Another ship set sail for Antarctica, and it was funded by Great Britain to find out, first of all, where the South Pole was exactly. That was the main purpose of the trip, but also to find out, well, see if you see anything interesting down there. We're kind of wondering, do they have any plants there? What kind of animals do they have there? Bring back some samples if you can. The ship got to the Antarctic, and they found plants that were very similar to plants that were found in South America and in Africa. And that's kind of weird because they're really separated pretty far. How could this possibly have happened? They found rocks that were very similar to rocks that were found in South America and Africa. How does this exactly happen? And eventually they came to think, well, at one time, maybe the Earth was one giant piece of land, or or at least those three places were one giant piece of land, and it broke apart and they ended up where they did. Eventually, that came to be known as plate tectonics. And that was something that had never been thought of before, but the work that they did, just sort of as a sideline, helped create this whole new science and help us understand what the Earth was like after it was formed and what happened in the fairly recent past. In the 1920s, there was a guy who was hired to be a technician in a laboratory. It was a place that grew gerbils. And he was not a very educated guy, he was not a scientist, he was just hired to do the grunt work. And the grunt work was, he had to find out when they were actually guinea pigs, not gerbils, when these guinea pigs would be ready to mate so that they could make more guinea pigs to sell to scientific labs who used them for scientific tests. Now the thing with guinea pigs was it was not easy to tell when they were fertile. And so he spent a lot of time using a little brush to reach into female guinea pigs and take some scrapings and look at them under a microscope. And by doing this, he could tell when they were fertile. And he was very successful with this. And then he began to wonder, I wonder if this works on human women as well. So he spent a lot of time with his wife and found out that, yes, he could tell this. And he was terribly excited about this and started talking to all kinds of doctors and said, oh, look what I can do. And the doctor said, yeah, that's really not of any use to us. Thank you so much. What would be really useful to us is if you could tell us when somebody's getting cancer. That would be helpful. And he thought about it, and he got samples of cancer from doctors who had samples of cancer, uterine cancer, and he figured out a way that he could tell by looking in the microscope before the cancer started forming. He was positive of his results, but nobody believed him. He was able to finally convince a friend of his who was an artist to draw pictures of the precancerous, the way the cells looked when they're precancerous. He had enlargements made. He got the city of Atlanta to agree to test 21,000 women. And when the results came in, there was a big room with people sitting at their microscopes, looking at the slides, looking at the pictures, and they identified 550 women who were precancerous and were able to treat them before it was too late. All of these things were general science. You have to have information before somebody can figure out what to do with that information. You have to have a vast base of information. Just as you have to have a lot of land before you can build a house, you have to have this information. Unfortunately, many politicians think that unless you are going for a specific goal, there's no point in giving any kind of money. But if you wanted to predict cancer, you have to have something that will, some kind of test that will give you that. And me saying to you, Cherry, I want you to find a test to predict cancer, what can you do to figure out how to do that? You're going to have to look at other things that have been done. You're going to have to do a lot of research. The reason that general science helps all of us is because it provides the foundation that we need to make scientific advances. Saving a little bit of money right now is going to cost us in the future. If you look back on the voyage of the Beagle, where we discovered evolution, the trips to Antarctica, where we discovered how the Earth was made, and tests done with guinea pigs, where we found out a test that predicted cancer, the very first test that predicted cancer. These are all benefits, and who knows what benefits we're losing now by not paying.